Hi everyone, today we will talk about Kubernetes requests and limits, or in the other words, how to manage containers resources in Kubernetes. So before we start, here is a quick introduction about myself. My name is Ahmed, I'm a DevOps engineer and I'm part of the infrastructure team at Camunda. I am interested in the cloud computing and Kubernetes topics. Also, I'm working with open source for many years now in my free time. My favorite topics all the time are DevOps transformation, automation, and working with data in general. You can find me at LinkedIn or my tech blog where I write some interesting posts from time to time. So, here is our agenda for today. Let's start with the overview. As you know, Kubernetes is a platform to manage and orchestrate containers workloads. Kubernetes has a mechanism to manage containers resources in the cluster. That mechanism doesn't only affect the resource usage, but also how they are scheduled. Or in other words, what will run where. Today we will have a look on how Kubernetes manages the container resources, also the types of those managed resources, then three different ways to set containers requests and limits, and the difference between cluster capacity and allocatable resources. Finally, finishing up with some tips to recap this session. Let's have a look on some basic concepts. I assume that everyone knows what are containers. So Docker is the software to build and run containers, and Kubernetes is the platform that orchestrates containers resources and containers workloads. Now let's take a look at Kubernetes concepts. Starting with the Kubernetes cluster, which is simply a group of nodes working together to run containers workloads. And Kubernetes node is the actual computing power. It's the source of resources for the cluster, where the pods and containers are placed. And it could be a dedicated machine or a virtual machine or even a Docker container. On the right side, you can see a simplified diagram of a Kubernetes node. And finally, a pod, which is the smallest building block in Kubernetes, and it could have one or more containers. Think in a pod as a single machine. And on a single machine, containers can share many things between them easily, like volume and network. Now, let's take a look at container resources management in Kubernetes in more details. As you can see here on the right side, this is an example of setting the requests and the limits for containers in a pod, which is, I think, the common way to do it. And it's per container within the pod. Later we will see the other two ways to do it. It's important to mention here that requests and limits are not just important for resources management, but also for workload stability and capacity planning. We will have more details about this in the next slides. The question now is, what actually requests and limits are? As mentioned before, they are mechanisms used to control container resources such as CPU, memory, and ephemeral storage. And if you didn't work before with the ephemeral storage in Kubernetes, we will have more details about it in a minute. So, request settings are what the container get when the pod starts. It's the minimum resources needed to make an application works as expected. Request is also important for workload stability and capacity planning. For example, for capacity planning, by setting the requests settings, you know how much needed resources to run your current and future workloads. For stability, let's assume that your application needs 2 gigs of RAM to work. And if you didn't set requests and limits in your manifest, then Kubernetes could schedule your application on any node, even those nodes don't have enough memory to run your application. And the application will try to run and it will fail, and it may be or maybe not run on another node with enough RAM, because simply Kubernetes doesn't know how much memory is needed by your application. But if you define the requests and limits in advance, Kubernetes will make sure that your application will run on one of the nodes with enough resources. Of course, if you have enough resources in the first place, or you already enabled auto-scaling. That's why it's important to set the requests to avoid all that hassles. Now moving to limits settings, which are the thresholds that shouldn't pass by the container. What happens after reaching that limit is a bit different according to resource type, and we will see more details about it in a minute. Like requests, also setting limits is important, because if it's not there, the container will simply consume all node resources and will affect other pods working on that in the same node. That's why it's important to set both of them. Now let's take a look at the resource types in Kubernetes. And there are 3 core types could be configured by requests and limits in Kubernetes, which are CPU, memory, and ephemeral storage. It's worth mentioning that those are only the core resources come with Kubernetes by default, but there are also other resources which are called extended resources, and they are provided by Kubernetes plugins or so, but they are out of scope of this session today. Back to the core resources and starting with the CPU. CPU here is referring to one virtual CPU or one CPU core, and it could be represented in different styles. So half of CPU core could be written as 0.5, which is also equivalent to 500 millicore. The second type is memory, which is measured in bytes and could be written as a plain integer or using a decimal or a binary suffix. Finally, local ephemeral storage, which uses the same notion as memory. And in case you didn't work with the ephemeral storage before, it's simply a temporary storage provided by Kubernetes, and it will be removed when the pod is terminated. It's using the node disk, or in more details, Docker configured volumes. It could be used, for example, for application caching or so. Maybe it's less known than CPU and memory, but also it could affect the scheduling of your application pods if used. So if you are using empty dir in your application manifest as a volume, it's better to set the ephemeral storage requests and limits, especially if those temporary files are crucial for your application. Now the question is, what happens if a container exceeded the configured limits? In Kubernetes, there are 2 different situations according to the resource type. In case of the CPU, if the container passed the limits, Kubernetes will just throttle the container usage. It will not allow the container to use more than what's configured, but the container will run and keep running. In case of memory or ephemeral storage, if the container passed the limits, Kubernetes will evict or kill the pod and recreate it again. It's simply because CPU usage is more or less like a queue, but for the memory and storage, they are space, and Kubernetes has no clue what's inside that space. Hence, Kubernetes has to evict the pod to free up the exceeded resources. There are more details about Kubernetes eviction mechanism, but that's a story for another time. By now, it should be clear what requests and limits are. Now let's set them. Kubernetes allows you to set requests and limits in three different ways. The first one, I think it's the most known one, which is defining it for a container within a pod. And of course, if you have more than one container in your pod, you will need to set requests and limits for each container. Now let's see the other two ways to do it. Kubernetes provides other ways to set requests and limits, which works on the namespace level. The previous one worked on pod level, but this or this and next one are working on the namespace level, which means it will be applied to all pods on the namespace. By using limit range, you can set the resources usage for every individual container in your namespace. For example, you can set the maximum CPU usage for any single container in that namespace, even the container has requests and limits configured. Also, you can set the default CPU for the containers that don't have the requests and limits configured. Please remember that limit range is applied to every single container in this namespace. That means if you set the default CPU to 1 and created 10 containers, then you will have 10 CPUs used by default. It's pretty useful for policy enforcement, especially in clusters with multi-tenancy. Now with the third way to set requests and limits in Kubernetes, which is called resource quota. Resource quota is also working on the namespace level, but it sets the resource usage for the whole namespace. For example, if you set the resource quota of the CPU to 10, that means one pod can get the 10 CPU cores, or 5 pods get 2 CPU cores each. Now, one more important aspect of the resource management in Kubernetes, what's so-called capacity and allocatable resources. As mentioned before, Kubernetes node is the source of resources for the cluster. That means the maximum resources available for any container is the maximum resources available on one single Kubernetes node. But actually, you cannot use all node resources for your pods. Why? Because the node preserves some of the resources for the operating system and Kubernetes cluster agent, which is called kubelet. The rest is called allocatable resources, and that's what you can use for your pods. So if you have a node with 100 gigs of RAM, you can use only about 75 gigs of RAM for your pods, and the rest are preserved for that to make the node working. It's worth mentioning that allocatable resources are vary between cloud providers. So what's on GCP is a bit different from what's on AWS and so on. But usually allocatable resources are around 75% of the total capacity of the cluster. And finally, let's finish with some tips to recap this session. So please remember that requests and limits play a key role in resource management, but also in application stability and capacity planning. Requests cannot be configured to be more than limits. Requests and limits cannot be greater than biggest Kubernetes node. Not all resources in Kubernetes node can be used to run pods. You get about 70% of the total node's resources. Pods with no requests and limits are more likely to be evicted first, so make sure to set them for better stability. When you set requests and limits for the first time, start with a small value, then adjust by monitoring your application usage for accurate values. And always remember that inaccurate requests and limits values are waste of money and resources. That's it. And here are some references for more details. And finally, questions. Feel free to send them now or offline. And thanks a lot for your time.